Thank you, Sam. Yeah, it's true. We've been struggling with a lot of different ALM in the jungle and wide-scale open source in very heterogeneous environments. And sometimes it's a combination of just having a mix of different ALM tools, or sometimes there's just a complete lack of ALM, lack of traceability. Some of the things that you heard in Tom's keynote this morning, failing at large scales. So I'll just give you a really quick background of how TaskTop Technologies has fit into this picture. And I think for a lot of you, as you're looking through this talk, I'm going to share some experiences of what's happened in, for example, large-scale open source development, such as Eclipse.org or Mozilla.org. And the sorts of different tools that have been adopted and have grown over the years to support this style of development. If you've got vNext deployed with a nicely vertically integrated stack, you can do better than that in terms of that traceability. But if you do have this mix of heterogeneity, you have some open source creeping in, your organization has gone through some M&As, and you've got a mix of these tools, these are some of the patterns and best practices that we've learned to adapt to this heterogeneous stack and to adapt to these new, very developer-centric tools that formed in the jungle. So quickly on TaskTop, the Eclipse Mylan project, by virtue of connecting developers to the ALM stack, is now seeing about 1 million downloads a month. So it became this task-focused ALM interface for the IDE. Basically made the IDE feel like a Microsoft Outlook for developers, and I'll show you why, by connecting them to the different ALM servers that they had. So not just the one Exchange server, but this weird mix of servers that often formed organically within our ALM stacks. To do this, to hook up developers to ALM, we created this thing called the Task Focus Interface. So that's my background. That was my PhD thesis. And then this new layer, this common open source data model where we can make the ALM tools talk to each other. So I'll touch on that as well. And as a result of those two things coming together, we've ended up supporting a lot of different ALM integrations. So both through TaskTop and through this broad ecosystem of tools that have built on top of our open source APIs. So the Mylan ALM APIs, which is a set of Java APIs, and more recently a set of REST APIs for integrating various ALM tools. So you'll also see the stuff working within Visual Studio. We've been working very closely with the leading vendors in ALM to make this happen. So both the larger vendors in vertical stacks from Microsoft, from IBM, and from other organizations, as well as the best-of-breed tools, such as ThoughtWorks Studio's tools. Now, this is the mix of tools that we currently support. So we've got a very wide variety, again, spanning this, the large incumbents, the best-of-breed solutions, and then these open-source solutions that tend to be point solutions. There are over 70 of these. So I think I remember one of the Forrester analysts mentioning that on one of the surveys, for which issue tracker you used, there were 100 different answers. So it's gotten very mixed out there. It's gotten very heterogeneous out there. A lot of the tools do similar things. Some of them really do have different approaches. Some are more traditional in terms of their approaches to requirements management. Some are more agile, and they're pushing the envelope of how we do agile requirements, or even how we get into BPM. But for a lot of us, what's been happening is that when I show this slide at a customer meeting, it's very often I get, I say, oh yeah, we use about 20 of these tools in this company for organizations that have over 1,000 developers. So this has been a big mess, and it causes pretty big problems. And I think a really neat instance of a problem that caught my eye a couple years back was this plane that I was hoping would make my frequent travel more comfortable and fuel efficient. But then this headline said that there was yet another delay in the 787. And the problem wasn't that the brakes didn't work, which is good to hear. The problem was that the traceability it was in the traceability of the software. And the GM, the general manager for this project, said he was confident they'd work this out. So it took a little while to dig deeper into what had happened here because there was no detail. But what happened is that we're now in this complex source environment where you've got contractors, you're building on open source stacks. You no longer have all your source code for a system, like the 6 million lines of code that run the 787, coming from one source. And the requirements for the brake system were specified by Boeing. The implementation was passed off to General Electric. General Electric passed off to some French contractor I forget the name of. And so there are different tool stacks in the mix. And what had happened is that there was no traceability between the requirements and the source code. The odd thing about it was that the brake system actually passed all the tests. The whole thing worked. And in the late stages of certifying the software to make sure that Boeing could maintain it, this was uncovered. And by the time it was uncovered, it was too late. Everything was paid for and completed. And Boeing has, so the other interesting about these airplanes is they have about a so in terms of software life cycle, they push the envelope because they have about a 7-year life cycle that they have to maintain. So 35 years active production and then another 35 or so maintenance, where they're still flying and still have to, I guess bugs have to be fixed in the brakes. And so Boeing has a very good model of what it costs to maintain software where you don't get traceability from the source code, so from the implementation back to the requirements. If one of the requirements changes because something's changed about the brakes, the way that the brakes should work, it's a lot of rework to address that. And this traceability problem is a complex problem. For a lot of the software that we write right now, we're simply missing it. Again, you've got a nicely vertically integrated stack, you're fine. You've got the traceability if you're purely in TFS and vNext. If you've got some complex sourcing going on, you've got a part of your organization that's using Jira, a part that's using Subversion. People are moving to Git now because it's the latest hot SCM system. You end up with this problem. And the cost of this problem is not always immediately evident, but it's a very high cost. And it actually caused Boeing to delay this plane a couple months or so. So it's a tough problem. And in some of my conversations with Sam about this, he related to ALM, to the way that ALM is formed in our organizations, to the London tube system. So this basically layering legacy on top of competing vendors trying to get a bigger and bigger piece of this network. That's, for our ALM stacks, it's the place where we capture the work items, the tasks, the source code. And they're competing vendors, competing for parts of your organization. If you've got a large organization, some will win over one camp of developers, some will build on top, some will be more geared towards the quality management people, some more geared towards the requirements management people, some more geared towards the developers. And we've just built layers and layers of this legacy into our systems. And the cost of this is that we don't have that traceability. So even if you have a plan to modernize your ALM stack and move to a single vertically integrated stack, it could take you years. So for organizations trying to, some of these tools have become very entrenched in the way that we work. So tools like HP's Quality Center, most organizations realize would take years to pull out because the test plans are entirely captured in that tool. And there's been all this customization that's happened. Many people would love to completely move off ClearCase at this point, but it's not easy. And again, because of those customizations, and because these ALM tools, I think, they're so key to our software, they're the knowledge base of our products lines. So even though we've got an inferior tool, the fact that we've got that whole knowledge base captured in this spot is relevant. And again, we've wrapped all this legacy around that because of the customizations, because of in-house extensions for features that we were lacking. All these reporting tools that weren't there before. So I think we need to move away from this messier world into what this really neat thing that did happen in the London tube system when this guy, Harry Beck, got tired of looking at this messy map. And in 1933, so this is an 1889 map. So it got, if you've been to London, it got a lot more complex than this. But he simplified it first by taking a look at the architecture of the system. He actually shifted the whole display of the map from being a geographical map, so just a topography of London, to being a schematic map. And overlaying the different lines with different colors. And really, the London tube system is now usable. And I think we need to take a look at, we just accept, for those of us who don't have these seamlessly integrated vertical stacks, those of us who've left right behind, adopted Agile, and ended up with some open source in our stacks, even as we're trying to bring more and more into a single ALM system, we have to deal with this legacy. We need this stepwise incremental approach to to move away from our legacy, to modernize our stacks, and in the process, deal with the heterogeneity that we have in place today. And really take a look at ALM architecture, not just as a tool, but as an architecture that involves these multiple components, multiple stakeholders, and the traceability that's needed between each of them. So the problems that we end up when we don't do this is these big disconnects. Like, for example, if the developers and engineering have chosen the tools that they want, those will be completely disconnected from traditional requirements management, project portfolio management, quality management, and the like. And developers will be annoyed because they have to do duplicate data entry. They have to update a requirement, for example, in a separate tool. I've actually met someone whose job it was to take things that people had written in Jira and write them manually into Quality Center. That was half their job. And the other half was trying to automate some of this. And you've got uninformed managers because you have filtered information and you don't have any real-time visibility or traceability if this heterogeneous landscape is not connected. And the two things that have really exacerbated this disconnect are, I guess, the really reactions to to what we had 10 years ago with this beautiful vertically integrated stack that developers hated called the rationally unified process and that tool chain. So Agile was this big reaction, and the lightweight open source tools, the Subversions, the Hudsons, the Jenkins cruise control, and the like. So if we look at, now just step back from that a bit and look at how ALM has happened in the jungle, I think there's some key lessons in what's formed there. Partly because we already have some of these components inside our ALM stacks, and partly because there's been some real innovation on the open source front around ALM that's completely forgotten about the constraints of requirements management and the constraints of quality management in a lot of cases. So we've had these, I think, these two sort of parallel evolutions on the enterprise side and on the open source side. We've got, on enterprise, we've had this tendency to heavier weight tools. So especially from tool sets that did not put developers in the forefront, and I'll get back to that. On the open source side, things have been lean by necessity. So you had no budget. So if you start an open source project, unless, say, I don't know, 8 years ago, SourceForge provided it, you had no ALM tool set. You had an SCM system, and that's all you had to start out with. There's been centralization on the enterprise side. The open source side has all been about empowerment, especially, and I'm really talking more about the community-driven open source projects here. So the things more like Eclipse, more like Mozilla, more like what you see, a lot of the projects that you see popping up on GitHub, rather than the corporate open source projects. So things like Android or the Spring Framework, which are really, you have one corporate sponsor. Projects that have a foundation or a community driving them, I think have been really interesting to study. So on the left, you have a need for hierarchy. You have a need for centralization and hierarchy, and you've got contracts. You've got some projects that have to have some kind of confidentiality, limited visibility. On the right, you've got transparency. And all of those tools evolved around the stuff on the right, all those open source tools. So Subversion and Git and Mercurial, none of these tools have really evolved around proper access control or proper support for hierarchies. And that's actually wreaking havoc as they're brought into the enterprise stack. So there are these some really interesting things that happen on the right, but not all of them map perfectly into our enterprise stacks. And again, this ends up causing traceability problems. So on the right, it's all been around velocity. Developers who, whether they're moonlighting or they just are passionate about this particular JavaScript SDK that they want to evolve because they use it in their day job, it's really been about supporting that velocity that developers like. But velocity without some kind of predictability and traceability is useless if you've got shareholders that you have to tell what you ship in 6 months. And you'll notice from open source projects of this sort that a lot of them are very much community driven and they don't know exactly what they're going to ship in 6 months. So part of how effective they've become has been about responsiveness to the community, but those planning tools have not really been there. And if you look at the open source stacks that we have today, there's not currently, as far as I know, a compelling agile planning tool, for example. So XPlanner was a flop. This was an attempt at an open source agile planning tool. Because developers in open source have focused on the tools that they needed for that right side of the equation, not the stuff on the left. And so there's been this sort of double-edged sword at this point of this focus on developers. So some of the traditional ALM vendors have lacked this. I think what's interesting with Microsoft is developers are so deep in its DNA. It's been different. You can see in VNext this very deep focus on developers. But the focus on developers in the open source stack has been it's been complete. It's only been about tools from developers for developers. And there are three key things that, in studying this, that I've noticed the successful open source projects have. So they have a way of managing tasks. managing the source code, and then the build, the CI system. So basically change management, source code and configuration management, and continuous integration. Not all projects have this, but you'll actually see that projects that manage all of their their tasks over email tend not to be as successful as the ones that have some kind of proper issue tracker. So the projects that have been successful in terms of engaging volunteers and community members and contributing tend to have these three things. And because they had no budget for creating them, for buying them, they created them. So we've got tools like Bugzilla and Track and Mantis on the issue tracker side, CVS, Subversion, and more recently Git, Cruise Control, and then Hudson Jenkins. And if you look at the Eclipse Community Survey from 2010, also 2011, the numbers are similar. This is a survey not of Eclipse developers, but of all the consumers of Eclipse. So it's actually, I think, about a third or half of the results are organizations over 5,000 employees, the respondents. And the number of I should have written that down. It's about 2,400 respondents. You see that if you put those tools together, and this is, by the way, very heavily weighted to the Java side, the Java, PHP, mobile, embedded C, and C++, not the .NET side, because it's Eclipse. You'll see that the open source tools have more, if you put just those logos together, have more than half the market share in each of those categories. So they've made this big footprint in the enterprise. Bugzilla in this part of the developer community, which probably represents about half of professional developers, has as much footprint as Jira. And Jira is actually a pretty face on the same model as Bugzilla has. What Bugzilla innovated was, that has a longer legacy with things like Jitterbug, but it was the fact that collaboration happened on the issue tracker. That thing had comments. Legacy tools, like the old versions of Quality Center or ClearCase, those were not. Those were around this top-down command control. They were not about empowered developers commenting to each other and having all of their collaboration around the issue tracker, which could be linked back to the code and to the rest of the project. So I think the key thing here is that these things, and the reason Mylan got popular to that too, is that we connected these things up. So we just added traceability between those things. We put them into the developer's workbench, into the IDE, and we link them up so that projects could work on them they could have this single stack for managing their ALM. Now, it was really tasks and context that we used, and this was the disruption that we made within the IDE to do this. It came from this problem that we saw. So this is sort of going back to my looking at the way developers were working in organizations and comparing that to the way it was happening in open source. And I did a sort of longer study of professional developers in industry. This is before I ran the company when I was still doing my PhD. The results I had were very similar to these more recent results from the Transactions of Software Engineering in 2006. If you look at a professional developer's day within the IDE, they waste more than half of it. And this is not, this excludes meeting time and or Facebook time too. This is just time that the developer thinks they're being productive. The handling of interruptions, navigating source code, which is exacerbated by interruptions, always searching for new parts of the source code and switching applications into their issue tracker or doing a command line commit, all of those sorts of things take up about half of the developer's workday. So what we set out to do is to make an abstraction that could tie these things together and do these two things. Tie the developer's activity around code into the ALM system, and then connect up basically the disparity we had in these different ALM systems. And for this, we came up with this abstraction of a task. And we basically tried to come up with something on the application development side. We've had this very successful abstraction of a file. If you try to get rid of a file, you end up with things like IBM's Visual H for Java, which was just a flop because it had this beautifully elegant Smalltalk-like database model and no files. So it had a hard time talking to app servers. There was not a good, files have been great for interoperability in this abstraction for content, for source code, for binaries and the rest. And we tried to basically tie something into the developer's workspace and to tie these different ALM tools together with this notion of a task. And tasks just have a structure, this key thing of a conversation. Because if they lack this, as we've seen in some approaches to ALM, the conversation falls back into email, IM, and phone calls, which is sort of hard to track historically. And then the context. And that context has to be built up automatically. I'll show you why in a moment. So this structure is just some kind of process, like an agile process. You've got attributes like your time boxes and the like, and you've got workflows if you've got a sophisticated process. The conversation can happen in multiple places. It has to come back to the task. Even if if the conversation originates with a user discussion in a help desk system, then comes into QA, then to dev, all of this needs to be captured as a part of the task. In open source, what's really important is that we have, I guess what's also different is that we have a very public conversation about our software. Everything is completely open. So the Eclipse Bugzilla is anyone. It's like Wikipedia. Anyone can write to anything, and they can change any field. And anyone can create a new task. So there's just no governance. There's no control. Also, anyone can complain about this thing that we just added to Mylan on Twitter, and they do all the time. So we had to make sure that we took all of that conversation and whatever media was happening. So basically, the mailing lists, the comment thread on the task or defect, and all the Twitter conversation, and we attach it to the task. Excuse me. So that when a developer looks at this, they know that everyone's been complaining about this new feature that was added, but their complaints have been happening in a social medium rather than in the actual issue tracker. And then the context. And capturing the context, you just need all the code, all the documents, all the builds, everything that's attached to this task. And I'll show you why in a moment. So actually, maybe I'll just show a quick demo at this point, and I'll show you where this has ended up in terms of the developer's experience and then how it ties these things together. And I'll just show you the open source tool set inside the IDE right now and the way that these developers work. So we've got over here the ability for the developer inside the IDE. They can attach to any place where their tasks are. So I've got over here, this is a contributor to the Mylan project. I can look at this is their task list, and their task list is their inbox. They don't use their email inbox. All of they get notifications in their email inbox. But over here, I can see exactly the history of every task, every attachment that's ever shown up on it, all these context attachments and patches. This task is a little old, so it looks like it predates our use of Git, so there are a lot of patches happening. Word documents, anything related to it is showing up here. So it captures the entire conversation between the developer and all the other stakeholders. And if there were any tweets on it, the tweets would show up here. All of these things are captured in this task, and this task aggregates all this information from potentially multiple repositories. So one SCM tool, one issue tracker, one social tool, and so on. Now, an interesting thing about the way that these tasks run in open source, you'll notice we're actually only expanding the most recent comments because a lot of these tasks they'll get over 100 comments very frequently. So we get, in Eclipse, on Eclipse itself, there are 3,000 new Bugzilla bugs created every day. And, every month, I should say. 3,000 new Bugzilla bugs, a day would be a lot. 3,000 new Bugzilla bugs created every month. And so both the developers need a very easy way to manage these very large volumes of information, because another key thing about open source, you've got this huge disparity between the number of people consuming the tool and providing feedback as compared to the number of developers. And for those community projects, no support organization in between. No one doing the triage rather than developers. So things like duplicate detection over here. If I want to make a new bug on eclipse.org, and I made it from a stack trace, let me just try to find the real stack trace. All of these things, they're not even options for us. If I report this bug to eclipse.org, from Eclipse, you'll notice that we can obviously report bugs from the IDE itself. I can, with a click, search for duplicates. And we've had to add all of these features just to scale with the volume of task-based communication that we have with our user community. And oftentimes, it's not been us that's added these features. So there are all these different strategies for duplicate detection. I don't have any of them installed. There are communities created for people who spend a lot of time triaging bugs for themselves. And of course, everything is linked here. If I actually wanted to go, if I submitted this bug, I could very easily navigate to the source code related to it, because we've linked everything up in the IDE, as you'd expect. Now, all this interaction has been captured on these tasks, and the contexts are all captured and shared. So like the demo that you saw with vNext today. So all I have to do is activate this task, and I'll see everything that this contributor was looking at. All the files, I see the IDE is now completely focused around these tasks. I click a new method, and this method gets added to the context and will be shared with the other developer once I decide to share my context. So rather than the views showing everything, where you very quickly on a normal-sized Java or .NET system, you lose the forest for the trees because we're now building on millions of lines of code, either in the form of our own source code, our own source, or the binaries and the SDKs that we build on. Everything instantly focuses on the task, which makes it very easy. This is the important thing. Makes it very easy for developers to share knowledge about the source. Everything that every contributor does on the Eclipse, on the open source Eclipse Milan project, is captured. And we don't accept patches without a task context attached, because otherwise you have to go and ask this person what on earth they're doing. Here I can actually see that they're using the handler service. This is an API. And it looks like they're adding basically IntelliSense type, so then it's called Code Assist in Eclipse, Content Assist in Eclipse, proposals on to the Bugzilla task editor, just from reading the class names. So what's happening is that we're capturing all the requirements, user stories, all of that on Eclipse is being captured in these Bugzilla bugs. And Bugzilla is just it's probably the worst that you can do in terms of having a modern issue tracker, but it's just good enough. So it's able to capture all of this thing. It's got the conversations. All of our conversations between developers are happening on the tasks. We don't use email lists for this. We don't have email, and we have no option for direct communication. You can't pick up the phone and call someone who you're talking with because you usually won't have their phone number, and you'll never have met them. And so you actually see the volume of this communication is quite large. It's quite large on the Milan project, and it's very large on Eclipse itself, which is composed of, the Indigo release is going to be between 50 and 60 million lines of code. So that's, I think Windows Vista was around 60 million. 350,000 tasks on Eclipse, 3,000 new per month, 1,000 committers, and 733 components. And each of those are sort of large projects with their own teams. You can think of each of those as teams and sets of APIs. And then 270 different Hudson builds running continuously in the continuous delivery process that's on Eclipse. So what's helped us scale this, both in terms of capturing the communication, making it possible for new contributors to come in and add what they're working on, is to capture everything on those work items, on what we call the tasks. And capture all that context automatically, because as in that boring example, if you don't capture it automatically, it won't get captured. If you don't provide that traceability, if you don't give developers an easy way of activating tasks, activating the work item that they work on, they won't. You actually have to give them this benefit for them to do it. Otherwise, you're asking them to manually add commit messages on every commit. And we know how well that works. So especially if you've got, again, in open source, it's even worse because you have no managerial control over the people contributing to your source code base. It's back to being like Wikipedia in the jungle. And we've had to put in all these facilities to manage this, and you see those captured in some of the the methodologies that we have, and in some of these frameworks. So the other thing that we've noticed is that we had to have transparency. So we could not, there was much more, Milan actually came out of, so I was at the University of British Columbia in Vancouver at the time, and there were not many resources behind that project. So it started forming when we hit this sore point in terms of developer productivity. It was actually increased a growing number of volunteers that were contributing to it. And initially, it was just myself, one other person from the university, and then this growing number of people in their spare time who just wanted proper access to first Bugzilla, then next we did Jira, then we did Track, then we did, then it just went on to do those dozens of different issue trackers, and then later SCM systems, and later the CI tools. And what we noticed is that if we captured that information, if we had the task context, we could make it very easy for people to contribute to the project itself. So what we did is we added all these facilities that drove transparency and traceability in our source code base. And task activation was, again, this unified notion of a task was the key thing. So if we look at the way that Mylan developers work in the wild, I'm just going to show you a visualization. I'll get back to the tool and show you how it manifests in the tool. But this is Gorse, that's another open source project, visualization of commits happening on files in Mylan. And you'll notice this clustering happening so naturally. You can do this for other open source projects as well by running Gorse on their source code base. And the clustering aligns exactly around our tasks and sort of cascades into the module boundaries that we have. And sometimes you actually notice these clusters go off to the side. Those will actually break off into these separate units of functionality with their own sets of tasks, tying the source code commits together, and we'll break them off into separate projects. So we've now got a large number, over a dozen different projects in Mylan that, as teams have broken off, brought on their own contributors like focused models, new support for version control, and so on. So all of these things have been captured in our source code base, and I'll show you the way that they've been captured. And again, this is some of what you should expect in a vertically integrated stack. What we've done here is support it for a heterogeneous stack. So if I look back at my Eclipse IDE, and if I open up any class, so I can just navigate to a class, and I look at the history for this class, so it's now fetching this from the server, I'll see that every single line of code, oh wow, that was actually a commit I made. Every single line of code is linked back to the task that it came from. And it's linked back automatically. Because when developers have the task active, that linking becomes automatic. So by realigning the IDE around tasks, we can connect the CI tool, we can connect the SCM tool. I'll show you the CI tool in a second, to make everything explicitly linked. And we can go into any entry in the history and open the task corresponding to this entry, even though this might come from a different system. And then we see the attachments. For example, we see the screenshots. So someone was looking at some screenshot over here and didn't like something. We can look at the patch, so we can apply the patch from this. And then we can look at things like their tasks. So there's the patch and the diff. And we can look at things like their task context. And so now retrieve the shared task context so I can see what this person was doing 6 months ago in case they got hit by a bus and I now need to work on this feature. Or in our case, in case they got bored or got a better job at the bank that they were working on, so they no longer were interested in contributing to Mylan. And that's what happens on these open source projects. You've got no control over your contributors. 1/7 of our contributions come from non-committers, so people who are not even part of the project. They're just these volunteers adding things like you might contribute to a Wikipedia entry. And we have to capture this information. Like other successful open source projects, if we didn't have this full traceability, we would not have survived. Because we don't have, all these open source projects, some very key ones, are under-resourced and they have to have this level of productivity, velocity, and traceability in order to get to where they've come. So we get all this traceability. And I'll show you one more bit of traceability that we get that's really key, because it goes back to the CI loop. And I'll show you how, in a moment, how this maps back into your days, into things like Visual Studio and TFS. So if we look at the Mylan builds, again, Eclipse has a ton of builds. So this is just the rich client that we made for builds. And you can see, there are over 270 different builds going on here. I'm subscribed to some of them. So I can open the Mylan integration build for the 4.1 release. And then again, because of this traceability, we see that everything is automatically visible. So for context copying, someone called Sean Minter here has made a patch. And we see from the build all of the tasks that were addressed in this build, so all the user stories, requirements, whatever they are automatically linked, and they're visible. I can always attach to a build and bring it back into my environment, so I can attach to its unit test, just run the failed unit test directly off the server and so on. So it's just little bits of automation that developers contributed on their own to make themselves more productive. And then we can do, for example, we can take this failed build and send it to create a defect for it in any of these repositories that we support. Because again, we have this common data model where we can take whatever the build output was, whether it was structured or unstructured. Here we have a Hudson build. This is just and we can then create a defect from this build, and those things will be linked up. And the key thing about this is that with the frameworks that we've made, you can leverage these in your enterprise ALM stack. So if you do have, say, instances of Hudson, you can actually take this build. Because we've now got TFS integration, we have full TFS support, so I'll go into that. We can do two key things. Oh, nice, thanks. We can access TFS directly from the Eclipse IDE. If your heterogeneous environment has you've got TFS as your server, but you've also got developers doing Java or PHP in Eclipse. You've got TFS accessible, building on Team Explorer everywhere from within the IDE. So I can connect to a TFS server. I've got a TFS demo over here. And I can start looking at my queries or team queries. Let's see, all sprints. I don't know. Hopefully it has some things in it. So it's now bringing in to my IDE all the tasks from those sprints. And I have everything immediately accessible at my fingertips over here. And this rich client, I can always pop into the TFS web UI embed in the IDE as well. But this way, I can actually do things like take a task from an open source project and turn it into a TFS work item inside my IDE. Because we implement the full mile and task model for TFS over here. Similarly, if you've got the reverse scenario, you've got open source tools, but you're in Visual Studio. So you've got, some legacy issue tracker built on Bugzilla that's been customized and it's still being maintained for some reason, or something built on track, or some other commercial ALM tools. So you've got Rally, you've got ThoughtWorks Mingle, you've got version 1 or something of that sort. You can access them all through this Mylan UI in Visual Studio IDE as well. So this is not yet integrated with the My Work view in vNext, but we're working on that too. And then, you've got this Bugzilla bug. Let's say you are in that complex source scenario. So you're building on a component from the Apache Jira or from the Eclipse frameworks. And your sprint now depends on this defect in an open source framework being completed. You can actually add that into your plan. You can put a dependency through a URL and have it show up inside your IDE. You see, the developers see that they've got these 3 defects in the Eclipse Bugzilla or in some other open source forge that need to be fixed, that their current user stories depend on. So what we're doing here is leveraging these frameworks to bring in wherever the tasks come from, whether they're from a different ALM system, they're from an open source solution, and bring them into your home environment. So as a developer, that's the IDE. As a project manager, that might be the web user interface. And I'll get back to that. Right now, you're just seeing the integration at the IDE level. So another key thing that we've learned is that storing this is on the focus so far on the issue tracking side, on the work item tracking side. And another key thing that we've learned is what's needed from the SCM system. And the reason that we've seen such a rapid uptake of distributed version control in open source goes back to this. The fact that if you look at the way that you manage your products, so in open source you still have products and things like user stories, tasks, in a distributed version control system, or you can represent those things, you've got those same concepts represented in the SCM history. So you've got commits. When a developer activates a task, in a system like Git, we can automatically create a branch for that task and get that same kind of traceability. So if someone wants to look at just the parts of the commit history related to this particular feature that's being added, that becomes very easy. In the legacy SCM systems, like CVS, like Subversion, you can't do this. So for that traceability I showed you, that was all based on line number information. It's actually imperfect. If you switch between tasks and modify 2 files, we've got missing information. In modern SCM systems like TFS and like Git, we've got this traceability. And whatever task gets activated, so you are contributing to an open source project, we can create that topic branch in that SCM system wherever the work item came from. So I think this really key thing, that's where I think there's been even more convergence in the commercial solutions and the open source solutions, because Git's not the only thing that supports this. Commercial SCM systems like TFS, like Perforce do support this. We're getting a lot of benefit from having the SCM history reflect what's happening at the project management level, what's happening with the user stories, what's happening with basically the collaboration, the conversation around the software, and having those things be linked up. So moving to a modern SCM system that has just these tremendous benefits, whether a commercial one or an open source one. And then, as I said before, the things they have to watch out for with the open source ones are that they're all about transparency. Setting up Git with access control that you might have captured in LDAP, those things are not quite there yet. So, but the way that these things evolved is, the way that Git evolved around the Linux community is in support of exactly this. So that you can have teams, individuals reviewing things and have a connected stack with traceability in the end is what we're getting. All right, then another key thing that I think I'll leave that this will be the last one that we go through in terms of the lessons from open source, is the role of automation and how important that's become to these open source projects. And I'll give you some personal examples of that as well. So if you think back to some of the motivations for Agile and the Toyota production system, the things that everyone focused on is just in time and lean. I think that's been really interesting to me in the way that's been adopted and used in open source as one of the concepts of lean manufacturing, is this weird mistranslation of the style of automation that was applied in the Toyota production system, which translates to automation. And what this automation meant that you wanted to empower the people on the ground to have this sort of, to have all the automation in place, but also have control over the production system. And it's pretty amazing the way that this has happened in open source and the way it's been evolving recently. Because again, all of the focus has been on the needs of the developer and what developers and contributors, including casual contributors, need to do to be able to evolve this piece of software. So and going back to the Eclipse Milan project, one of the key problems that we had was in the way that developers and casual contributors had the amount of work that they had to do to contribute to a project. So if you can imagine in your own organization, the sort of ramp-up time it takes to get someone set up with a workspace where they're ready to contribute to a project. With the most modern ALM stack, that becomes easier because you can do things like connect to a release and check out some of the right source code and get some of the right builds once you've got that integrated stack. The moment you've got third-party dependencies in there that build with another build system, the moment you've got source code coming from an open source SCM system, this completely falls apart. And so one of the big barriers that we had to contributions is that developers could connect to the issue tracker and all the information was there. They could figure out the right things to check out from the SCM system and build the source code. But they would always give us broken patches. So again, think of, in your organization, it's as if you've put in place the transparency to make it, you've got a consumer of a component on one side of the company, you've got a producer of that component, you're using different ALM stacks, and it's very hard for the person on one team to contribute an API enhancement to the person of the other team. So this was getting in our way. And I'll show you some of the community of developers around Milan created to make this process easier and to automate the ALM stack end to end. And these are really the application development management tools, not quite the ALM tools. There's, again, nothing here on reporting. There's nothing here on agile planning. This is just those just those core developer tools of the CI system, the issue tracker, and the SCM system. So I'll show you just one more demo. So let's say that I want to make a contribution. Again, keep in mind that there's the great UI talk this morning. It's basically the complete opposite of the way UX, user experience, happens in open source. So there's no formal review of any user interface. Again, it's in the jungle. It's much more like Wikipedia. Someone doesn't like a menu that we put in Milan, they give us a patch. Someone wants a different icon. Someone wants some user interface sugar to make something that's 10 clicks be 1 click. those are patches, and we're constantly looking at those patches, and they were constantly broken. They weren't building. Because we had not, and this has been a big problem in terms of this disconnect, some of the DevOps disconnects, the fact that it's very difficult to set up for a developer to attach to a build environment where they can simply add contributions, they can run all the unit tests. There's a lot of manual work involved if you've got this heterogeneous stack, and we have a very, very heterogeneous stack. We're actually now mixed between CVS and Git, for example, and we're consuming things from other open source projects. We're consuming Apache libraries, we're consuming Mozilla libraries, and the like. So what we did is the Mylan community did is they wired all this together. So let's say there's a contributor who wants to change a label over here. So hello, ALM Summit, I want to say. What would happen in the traditional environment and the way that a lot of projects still run is that you would then run your local unit tests and you would build this, but you would then contribute as a patch and so on. What we've done here, and what our community has done, is they've wired in together Git, Garrett, and Hudson with Mylan to automate all of this. So a developer never has to build locally. It's like they're attaching to just a hosted build environment that's always building Mylan. So if I now commit this change, so I said hello ALM Summit, change heading. So I make the commit, and then I push this. So it's Git, so I have to commit and then push because I'm committing locally. So I now push this change. What happens is as soon as I push it, we've created there was a branch automatically created for this commit. Instead of it being committed to the main SCM system, it's been committed to a staging environment. And a build was spun up just for this branch on behalf of the contributor. So we've got this build now running in the background. Sometimes it actually takes a minute for the build server to spin up because it's only polling once a minute. This is the Hudson build server. So I'm actually going to force running it right now. But it'll have noticed that there was this commit happened from a contributor. It's running this build, and it's going to give them feedback without a committer on the project, who's a very scarce resource. They're like the architect in your organization, ever having to look at that. And again, one of the reasons we don't have this collaborative process in our teams is because we just don't have the bandwidth to handle these kinds of contributions from someone outside the core team. In the case of Mylan, not having the bandwidth would have slowed our evolution and would have slowed our trajectory. We actually depend on that bandwidth from casual contributions from people outside of our nuclear organization. So now I see that there's been a build that's failed. And as a contributor, I see that this build was done on my behalf. I didn't have to do it in my local workspace. I just click it, though, attach to the hosted build, and now I see some unit test failed. So let's say I'm as lazy as we sometimes see people being, and I don't even bother looking at this now. But I can see that my changed files, and a code review was created for me automatically. Because by contributing, all I've done is tried to commit to this open source project. What that triggered is the creation of a Garrett code review. And that Garrett code review, at the right step in the workflow that we've created and wired in together with these open source tools, is going to involve a committer. But it's not ready to involve a committer yet because I broke the build. So if I now go down, I can see that the build server is one of the collaborators on this code review. And the build server runs all the tests, it runs all our API scans, it's actually attached to it can be attached to the Eclipse legal process and all of those sorts of things. So all the automation has happened around the CI server, in this, as Eclipse has adopted this continuous delivery process. And I can see that it failed. So now there can be someone, if I as a committer want to help this person, I could look at their patch set, see what on earth they were trying to do. And then in this patch set, I see that they changed the string from hello world to hello ALM Summit. This can be in my own workspace. I would have had a notification that someone is committing this in my task list, and I could decide to look at it in order to help them out. I could add a comment saying, take a look at the unit test. And at the moment I hit OK, this is sent back to them and to their workspace. So now as the contributor, I can actually look at the unit test. I go, OK, I forgot to add to make the change in the unit test over here. And I can either run the unit test locally, or I can look back at the build that I was looking at before. So I was looking at this build over here. I can say, OK, show me the unit test results of what I messed up that are failing. So those are the failing results. I just made the change locally in my workspace, and I've attached to the build specification and the test specification, and I've got the source code. So I can just run this test locally in my workspace now and be a bit more diligent about it before I then go and commit this for the rest of the organization to look at. So I then go team, commit. I'll have to grab one more thing here. There's one bit of automation we don't have, which is I need this long ID. That still has to be added. So I then commit this. I tell Garrett that I'm amending a previous commit and put in this long GUID, because that's the way those tools work, sadly. And now, when I push this for the automated code review process to look at it, the change will then be picked up by the build server. The build server will rebuild this thing, and then we'll see what happens. So the build server is going to take a moment to run over the code base and do this part of the build. So I'll just keep hitting refresh to see when it happens. And then if we fix the problem, we'll see that the build has now been approved. And this can move in this next stage. Now that the automated part has been done and has been captured in our infrastructure, I see the build succeeds. So the build has a success. I see that my code review has an incoming message on it. And I see that a new patch has been uploaded on my behalf, that Harry Hudson, the build server, is now happy. So he's +1'd it. And now, as contributors, we can look at it and say, OK, this change does make sense. Let's apply it to the main line. And the moment that we do that, so let me go back to the slides. Let me just run through this again. So the build is pushed into the staging environment that's been set up for all contributors. Anyone can do this. It's pulled by the build server. The build server goes back. If it passes +1s, if it doesn't, then the contributor can just iterate till they get this right. But the important thing is that the entire build is hosted for them. They simply attach to it from their IDE. And the moment that happens, the normal code review process is triggered. So the committers, as soon as they +2 this, they say, 2 committers like it, it's going to get pulled in to the main line, to the Git repository. That night, it's going to get consumed by thousands of Eclipse developers. Then later that, there's 6-week cycles on Eclipse. Later in that 6-week cycle, it's going to go to possibly hundreds of thousands. And then in the next big Eclipse release, it goes to all Eclipse developers and gets pushed out through this automatic update process. And so we've been able to automate all of these things around this model of a task and plugging in these SCM systems. And again, we see this as a very good pattern both for this kind of open source contribution, but the kinds of things you now want to layer over top of your these modern ALM tools that you're starting to deploy into your stacks and integrate the benefits of those tools with any of these third-party tools, any things that you're consuming as open source SDKs, and any of the mixed ALM stack components that you might have inside your firewall. So what we're really looking at is, actually, we're a little short in time, so I'm going to skip over the continuous delivery portion and just talk a little bit about what we're seeing in terms of modernizing your ALM architecture. So when you're looking at your stack, I think the key thing is, the drive to make as much of this vertically integrated from one vendor makes sense because you're not going to get a better traceability experience than that. But again, this can either be a stepwise process or you'll never get there because you're stuck with some third-party system. You're stuck with, you might have CA Clarity because you're in a financial organization who uses that for reporting. And that needs to be integrated back into your ALM stack. So whatever your stack, the key thing is that you've got a way of giving developers a unified experience for looking at that stack. And whether they're sitting in whatever their home environment is, whether it's Visual Studio or whether it's Eclipse, and that's there now. And then that you've got a way of connecting that, both the components within that stack, so the traditional requirements management into the Agile tool, into the quality management, with some kind of federation technology that makes these tools talk to each other. And that those things can also talk to the things peripheral to ALM, such as the project and portfolio management system. So it might be Microsoft Project connected to TFS, but it might also be TFS connected to CA Clarity. Your help desk system might be from another vendor. It might be BMC Remedy, the market leader there. And to do this, we've set up we've taken that common data model, the extensions that we had on it, and we've hooked it up to connect servers. So in the same way, as you saw in the open source project, and this will be just a quick plug for the products that we have at TaskStop, we've got this way of integrating those disparate ALM stacks into the developer's workspace with Tasktop Dev, and of using that same technology of having one model that speaks to all these different ALM tools over the REST APIs in real time to connect the servers with this thing called Tasktop Sync, where you've got someone in TFS, but the QA people stuck in Quality Center, because that's their tool of choice. Tasktop Sync can make defects in TFS show up in real time in Quality Center, have someone, and vice versa. So developers can be working in TFS, all the reporting can be happening there, while quality managers are working in HP Quality Center or ALM or another open source tool. And all these things are working together. So I think the future of the ALM stack is to umbrella incorporate this kind of heterogeneity while you've chosen your tool of choice for agile planning, for reporting, for quality management. And for many of us, those will be best-of-breed tools. So with that, I'll end and take some questions. Thank you. Yeah?
When you were doing the
I can hear you. I'll repeat the question.
When you were doing the code reviews,
yeah,
I couldn't see what you were doing underneath it. Are you able to plug in multiple providers there?
For code review, yeah, we do. So I showed you again just what it's like in the open source and the way that we've scaled it massively on Eclipse. Now, you might have a different code review tool, and the key thing is that you can plug that in. So if you've got TFS and Code Collaborator, you need those things to work together. And the way we make them work together is through that same open source API. So.